let's look at another example of using identities to help us solve equations. So here we have an equation, and we want to solve for t. We want to find all the t values that between 0 and pi that satisfy this equation. All right. So now when I look at this, I see I have a sine squared of t and I have a cosine of t. Now, usually it's easier if everything is in terms of one trig function, sine or cosine or whatever, just one trig function. So what I'm going to do is use the Pythagorean identity. All right, I know that sine squared of t plus cosine squared of t is equal to 1. So if I want to substitute in for sine squared, I know that sine squared of t is equal to 1 minus cosine squared of t. Okay, so I can substitute this sine squared with 1 minus cosine of t. So that, or cosine squared of t. So that's what I'm going to do first. I'm going to replace the sine squared with 1 minus cosine squared of t. Okay. Now I'm putting in parentheses because that whole thing is a substitute for sine squared. Okay. So I have to multiply that whole thing by 2. And then this is 3 minus 3 cosine of t. So now I have everything in terms of cosine of t. Now I'm going to distribute the 2, so that becomes 2 minus 2 cosine squared of t is equal to 3 minus 3 cosine of t. And then I can rearrange it. All right. Now this is one where you're going to get a quadratic equation in terms of cosine. Okay, so I'm just going to set this equal to 0. I'm going to move everything to the other side. So I'm going to add 2 cosine squared of t to both sides. So it becomes positive cosine squared of t when I move it over to the right side. And then I have this 3 cosine of t. And then I have a 3 over here, and I'm going to subtract 2 from both sides as well. So that leaves nothing on the left-hand side. And so the 3 minus 2 becomes a plus 1. All right. Now that looks kind of ugly. But you can see it's a quadratic. I mean, you have something squared minus, something, a constant times something. And so what I'm going to do to help us make it a little bit easier, I'm just going to say, again, like I did before in example 2, I'm going to let r equal cosine of t. Okay, and then it's a little easier to work with. And then it just becomes 2r squared minus 3r plus 1. Now the way we solve a quadratic is by factoring it. Now you could use the quadratic formula. That's another option if you prefer to do that. But I like to factor equations, so or at least if they're factorable. This one's pretty easily factorable. I'm going to split the middle term. You can use whatever your favorite factoring method is, but I like to split the middle term. I'm looking at 2 times 1. I'm looking for factors of 2 that add to minus 3. Okay, so factors of 2 that add to minus 3 would be minus 2 and minus 1. So I'm going to split the middle term into minus 2r minus r. And then I still have this plus 1. Okay, because the minus 2r minus r is just the same thing as 3 minus 3r. But that allows me to factor out, to group these first two terms and factor out a 2r. And I'm left with r minus 1. And then the last two terms, I can factor out a minus 1. All right, so then I've got minus 1 times r minus 1. And then notice we have this common factor of r minus 1, which I can factor out r minus 1 times 2r minus 1. And now I've got my two factors. In order for the product to be equal to 0, one of the two factors has to be equal to 0, right? So that means either r is equal to 1 or r is equal to 1/2. 1/2 would make the second factor equal 0. All right, so I solved the quadratic. Now let's go back to the sine and cosine. All right, because remember r was cosine. So so this means essentially r equals 1 means essentially that the cosine of t is equal to 1. And r equals 1/2 would be the case where cosine of t is equal to 1/2. Now, we're looking for the solutions on 0 to pi. Okay, so this obviously has a lot of different solutions. Cosine of t is equal to 1. Basically, when t equals 0, or, it also is happens when t equals pi, right? Because, no, wait a minute. Cosine of t is equal to 1 only happens here. Over here, here it's 1. Here it's minus 1, right? The cosine is the x value. So actually, it's just t equals 0 on this interval from 0 to pi. Just t equals 0 is the only solution to that equation. On this side, we're looking at when cosine is a half. Okay, so go over here by a half. Actually, let me switch pens. It's a little easier to see it. Go over by a half and then go up, right? And then you have a solution right there, right? And you can look at the unit circle and find out that that's pi over 3. And there's another one, right? There's another one where cosine is 1/2, but it's down here. Okay, that's the other place where cosine of t is equal to 1. But this is what? It's 5 pi over 3. But that's not in the range that we're looking for. That we're looking just for t values between 0 and pi. So the only solution to this equation on that interval from 0 to pi is pi over 3. Okay, so those are my two solutions: t equals 0 and t equals pi over 3. All right, I'll meet you in the next video for the next example.